Good day, everyone. My name is Mika Rautiainen. I'm the CEO and founder of Valossa. Valossa is a company that does video recognition and content intelligence software. I've been working on this challenge of making computational video semantics for 20 years, first at the university, and then from 2015 on in the company that I founded, Valossa. And today we are going to explore what is the current state of computer understanding, what's inside the video semantics, with lots of practical demonstrations. So I hope you have an interesting ride with me on this topic. So it's pretty clear that the rate and the volume of content is increasing rapidly in these days. It is shown in lots of the reports that are being produced. For example, internet video in 2021 is having almost 2 billion eyeballs, and every minute in YouTube there's 300 hours worth of video being uploaded. So clearly the volume of content is increasing faster than the people on Earth. Some statistics say that even 82% of the IP traffic will be video in 2021. If you look at the IP as a delivery network, it has become basically a medium that is already working to deliver video in different applications. So it's clear that this explosive growth is unmanageable by the people. So you need to have something that makes sense of the data, curates it, even prepares it at some stage of the process, and then finds the target audiences. And increasingly, this target audience finding is becoming more and more difficult because there's so much content out there that you don't, as a consumer, necessarily know what is the best for you. The big ones are already working on this problem. So the platforms like YouTube or even Facebook as a media platform are already creating solutions that make sense of this content so that they can monetize it very aggressively. Those big companies have already hired large teams of AI scientists that are working on these problems to cope with this kind of increasing volumes of content regarding moderation, creation, or targeting the content, basically monetizing it in an appropriate fashion. These AI scientists are working towards cognitive video solutions, meaning that the computers are able to do the same jobs that humans are doing. They are not as contextually savvy than humans are, but they are clearly capturing the patterns and features that we are already capturing with our eyeballs when we are watching the videos. Valossa, as a company, has been around for 3 years. We were pioneers in video recognition API launch in 2017 at NAB show. After that, the large players have also stepped onto the game, and they now provide cognitive services in their cloud platform. We are focusing on media and entertainment, so we've been engaged with lots of customers, lots of broadcasters, lots of advertisers, video marketers, and other businesses working with video that are thinking how to use AI in their practical workflow problems or to increase targeting or monetization of the assets. What it means actually to make a computer understand video like a human. So if you look at the fabric of the software that we are creating, it analyzes the structure of the video, understands what are the scenes and sequences within the video, where things occur within those scenes, what are people doing in those videos, like what are the activities that happen, but also what are the objects and semantics in the video data. If you look at the scene here, most of the people after watching this kind of fighting scene don't remember the exact color of the jackets or the types of the jacket or what kind of objects were in the kitchen. Computer has a superhuman capability is able to actually discern what's happening at every frame, every sequence, and write that down faster than any human can. So basically it provides more information, more data from the videos that has been possible to create by humans. It also can help in categorizing the content or analyzing the semantics of speech in order to search and retrieve appropriate utterances or other phrases or important keywords and moments in the video. So everything entailing here is actually covered by the latest and state-of-the-art progress when it comes to computer semantics. We have identified at least 4 important use cases for media that are shown here on screen. Content compliance and safety has increasingly important when online platforms are being used and collaboratively with the people, and lots of data is being ingested in the platform. Facebook is the peak example of this challenge, and they are facing problems of moderating all that content that people are producing. And right now you can read lots of articles about the people who do that job. It's not a pleasant job, and it's basically, according to Wall Street Journal, one of the worst jobs in the media business to be moderating Facebook videos or pictures. So it's important to have computers understand and support and facilitate these kind of processes that are cognitive and tedious and might affect on your brains. Automated highlights. There's lots of content out there that cannot be really targeted effectively to the right audience. It's because people don't have the time to create sneak previews of every content piece out there. So the computers can actually help in providing automated highlights and summarizing the content that might find their audiences if just marketed properly. Real-time streaming. So there's lots of live streams out there that has lots of things that can be monetized in the moment. You can recognize the brands visible, the moments or the highlights of the live streams, or you can track if there's any inappropriate content happening on stream. For example, nudity or some other things like sudden violent events. The 4th use case is of course very traditional and obvious for media production. It's content discovery and profiling. So for content discovery in the production, there's a high volume of content being produced, and the ratio between the content produced and the final product, when you measure in the length of minutes, is very, very huge. So how to effectively find the right scenes and shots in the video so that you can actually be more effective in your projects to provide this kind of discoverability. That's also where the computer can help. Our products are based on kind of 2 key elements. The first ones are video and image recognition APIs that can be used to make sense of the media in a way where computers are logging every possible second and moment in the video and summarizing that content in a meaningful representation that can be read by other computer systems and then utilized in multiple applications. The second product line is video insights tools. When computer looks into the content, it can record a lot of data. It can find out if David Attenborough, for example, gets more face time in nature programming than the actual apes. So it can give you this kind of statistics. And of course, by having this new kind of data, the insightful data on your assets makes you a better decision maker when you are actually trying to focus your content on your prime audiences. Enterprise customizations. Often asked question is, how can we train the system to cope better with our content? So it's necessary for these kind of systems to actually adapt and adjust their recognition capabilities based on what it finds or doesn't find. For this, these customizations are now being developed as autonomous APIs for automatic training, but they are not production capable yet. So you can have some preliminary models by computers self-learning those models, but it's more effective to actually have a customized model building for your actual workflows. and be more effective with your AI system. What it means in practice to actually go through the videos. So it can find the semantics of the face, the sentiment of the face, the gender, the age, facial expressions, and the name of the person, as well as the spoken topics, spoken dialogue for that person. That can be used for profiling the content, finding brands, compliance, viewing, and so on. Right now, our AI platform is able to do comprehensive analysis. It can analyze and recognize all the people, thousands of visual objects, audio sounds, extract keywords, and also categorize the content based on what it sees and hears. I will show you demonstrations on these capabilities in this talk. So this briefly is comprehensive video recognition, comprehensive video AI. What it means in practice, so I would like to jump into practicalities because it's more exciting than just showing you PowerPoint slides. Let's start with the content that is catchy, computer-generated promotions. We collaborated with the Finnish production team that have created a movie called Iron Sky and let AI to extract highlights or actual trailer of that movie. So let's see what the computer actually picked up from that movie.
Pants are tight. Mission control,
Washington.
What was that, Houston? Hey, what?
Nein! Ergreift ihn! Nicht schießen!
Be real. Who are these guys anyway?
Nazis from the moon.
Ready to face the music?
You know the President of the United States of the Americas.
Okay, so who of you actually got the basic understanding of what the movie is about? So Nazis on the moon, right? Okay, so the AI was able to pick up the key elements by analyzing the actions, sentimental moments, and the speech topics, and then aggregate that information into meaningful reel of highlights. And this is, of course, one of the promises for the AI. So another example is emotion-based trailer. So for that, we analyzed a movie called Charade from the 1960s, starring Audrey Hepburn and Cary Grant, and asked the computer to summarize the emotional highlights. So this is what the computer thinks are the highlights of the movie when it comes to emotional.
Starting
parts.
tonight?
He trusts you. Besides, you yourself said women make the best spies.
Now, cut it out.
Alex, I think I love you. We've got to do something. I mean, any minute now we could be assassinated. Would you do anything like that? No, swing down from there on a rope to save the woman you love. Like the Hunchback of Notre Dame.
Miss Slappett, Bartholomew. I spoke to Washington, Miss Slappett.
Go ahead, Mr. Bartholomew, I'm listening.
Bag.
In the
Get it.
And that was basically the computer was using the information that it finds in the film, content, actresses, as well as the dialogue, analyzes that, and summarizes the romantic clips or the drama of the movie. This is what the AI can do with all the information in the. This is exactly what brains are also doing when they are watching the videos. It just doesn't keep that information in memory like the computer does. It's just the highlights and the pivotal moments and actions. If you look at what else it can do, so with, for example, the example of charade, it can summarize nice shots of keyframes or promotional shots from the content based on who are the most important people and when they co-appear. So this could be a productivity tool when you are actually promoting the content in your online services, for example. It can be done also. You can also do A/B testing and actually choose all of these screens and actually test which of the screens work the best for your audiences. It can be even personalized. Some people really are attracted to Audrey's face than the Cary Grant's face, and they might be persuaded to actually look at the content when they are shown scenes with Audrey instead of Cary. These are the new opportunities that the content is having when you're actually having all the information at hand. This is another example. This automated highlights from McClintock, also old movie from the 1960s. Lots of hero shots extracted by the AI. And the action shot actually contains lots of punching because we told the AI that, okay, please show us all the punching.
I don't want you kicking Fauntleroy in the knee.
He didn't do no such thing.
And none of this nose twisting.
All right, so profiling this content is quite trivial to the AI after analyzing the stuff. What else it can do? So it can, when it knows that the most important are visible, it can highlight those scenes for inspection. It also can list you scenes that contain certain activities. Like here, for example, at the episode of Quantico, you can actually find the scenes with jogging, which is here, easily using this kind of...
I am warm now.
Another example is compliance. So when you are reviewing the content, you want to find out if the content contains sexuality, mild sexuality, or suggestive content, violence, impacts of violence, threats, accidents, disasters. So we've trained a model that actually extracts all these bits and pieces of information and summarizes that into categories that are reporting what's appropriate or inappropriate in the content. Here you can see that it has recognized the bikini lady at the beginning, but also other things, like, for example, male nipples, or smoking. I need to reduce the volume. Or possible accidents like fires. The use cases for these are in the compliance routines as well as the video moderation in the online space. These reports can then be customized to the requirements of certain situations in certain markets that might have different levels of needs for this kind of compliance processes. For commercial aspects, it can analyze, for example, what's actually consisting in the food program. So it can recognize that this how to make a margarita video is actually about food and drink. That is the high-level summary. Then it knows that there's the margarita guy in the video making the margaritas. If you look at the visual categories, there's lots of man-made objects and food and drink, so that's also correct. It summarizes audio categories, lots of music and speech. Stylistically, most of the shots are portrait shots, and so on. For compliance categories, it clearly highlights substance use. Well, in this case, the person is actually is not drinking that, but producing it. If you look at the more details, for example, the audio track, it summarizes some of the ingredients of margarita, and you can jump, for example, into points where the syrup
Just
is
nothing
involved.
cheap, syrupy, all that triple sec stuff.
So
I wouldn't go
after-
there. And do not go for the
kind
mix.
Of, after putting the
Don't do
actual
it.
liquor in,
You'll be sorry.
the syrup
Or maybe
is
you
being
won't.
put
In which case, you should
on the
probably stop
drink.
watching this
So
video.
you can find these minute details even in these instructional videos and highlight those or then make them discoverable by people. The AI also recognizes brands, so you can find all the appearances of most famous brands and logos in the content, which is relevant in situations where you have things like, for example, live streams, and you want to monetize brand appearances on those live streams. And then, of course, the search and discovery. So it can resolve queries like, okay, find me Arnold with a gun. In those kind of queries, the AI is able then to combine all the evidence it finds in the visual and audio streams and find the appropriate scenes where, for example, Arnold is actually using the gun in the movie. So with these examples, you can see how AI can actually help on bringing more value from your content data. And we have lots of partners, for example, a large UK broadcaster who is using the platform in several of the workflow use cases. We have national customers in Finland who are using the AI to promote their content in online space or segment the news into meaningful stories. So in that respect, I would like to conclude my presentation, and hopefully you will have any questions I could answer. Thank you very much.
UK broadcaster. Who is the large UK broadcaster who's using it?
So at the moment, we are still in the phases where we can disclose that information. So hopefully later this year. Sorry about that.
Hi, I'm coming at this a little bit from an ignorant point of view, but can AI be used to de-risk investment in film finance, for example, or?
Could you give an example of the de-risking, what it means?
Right, sure, of course. It just means that nowadays when you want to finance a film, a lot of the investors want to make sure that the film is not a huge risk. So de-risking means that they're going to make money basically from their investment. So the de-risking is a big thing in film finance.
Right. So de-risking, I've seen some companies in California that are working on this problem. Those companies are trying to analyze things appearing on for example, on scripts, and then correlating that with box office success. And then you can create predictive models that actually predict the box office successes. I think there's one company called, don't quote me on this, but maybe it's Scriptbook or something like this. And they are doing this kind of predictive models, and they claim in their public outcomes that they would have been able to detect lots of these dud movies based on their predictive models.
What's the name of the company again? You don't remember?
So maybe after the because I'm not sure if I was having the correct name. Yeah.
What sort of levels of reliability can you get with this? I mean, I think in one use case, a large British broadcaster had to scan their entire back catalogue to remove a presenter who had become persona non grata. Is it reliable enough yet to do that without human intervention, or would you miss stuff?
For inappropriate content or?
Well, this was one individual, Jimmy Savile, who was prosecuted, was found out to have been a child molester. The BBC had him in lots of programmes where he wasn't necessarily listed as a participant in the programme, but it became they basically couldn't air anything that had him in it. So would it be reliable enough to sort of pick that kind of level of granularity up and reliably find, an individual in the catalogue?
So yeah, there are different levels of accuracies you can try to measure. Face recognition accuracy is one. Whether you detect nudity or nipple slips or whatever events that might be very crucial to broadcasting, the accuracy differs. Face recognition has been improving quite a lot in these years, and there are companies who are claiming that the statistics of recognition of people is above human performance. So if you look at this, it probably is true in the laboratory setting where you are cropping the faces of people. People are not so good at recognizing other people when you have only a crop of a central face, whereas the computers are. Now in media, what we have found is that actually the people are having lots of shapes, lots of positions and poses towards the camera. It's not as clear-cut use case than this laboratory setting measurements of face recognition when you have frontal face and almost like a mugshot kind of situations. In those kind of live context use cases, we have been able to reach about 90% accuracy on finding all the faces of people and then associating those with the names. This information, of course, varies between media, so we try to choose a very kind of a good representation of the media, but then there's the challenge of quality of media. So if you would have a content dating back to the 80s where there would have been bad quality tapes, blurry faces and so on, then the computer might have a kind of lower success rates on those. It depends on multiple factors.
Hi, thanks for the talk. I had a question about ownership and a legal question. Are you able to analyze, say, the Terminator and sell that metadata on to another company? Who owns the metadata for a film? Is it tied in with the rights in the film itself?
That's a good question. There are companies who are creating the metadata and selling that. For example, companies like Graysnote. And those companies are doing derivative works of the content, and those derivative works are then associated as the auxiliary data of the content. So my understanding and perspective looking at those use cases in the media is that this, transformative use is the right word. Transformative use of any copyrighted content is valid for the business unless the content producer itself starts producing this kind of content. There's, for example, the question of repurposing of content. YouTube is filled with this kind of remixes of existing creative works. The broadcasters are doing compliance edits on creative works. So there's lots of these derivative works in play as well. So the contractual rights are complicated, but the understanding is that this, in the US, the fair use clause covers the transformative use cases. So that's one of the interpretations, but I'm not a lawyer, so. Okay, it's time to conclude the presentation. I hope you enjoyed this talk and have a pleasant fair. Thank you.